Okay, so today we're going to go over the two-sum algorithm in Python. The two-sum algorithm is a classic problem in computer science. Given an array of integers nums, right, and an integer target, return the indices of the two numbers such that they add up to the target. Let's walk through a step-by-step tutorial on how to implement this algorithm in Python. The first thing you have to do is understand the problem, right? So before diving into code, let's understand the problem statement. We're given an array of integers and a target sum. We need to find two numbers that add up to the target sum and return their indices. So in this case, we're looking for 9. 2 plus 7 will equal our target, and we would be looking to return 2 and 7. So the next thing you need to think about is the approach, right? There are tons of ways of solving this problem. We're just going to go over a simple one. One way is by using a hash map, or a dictionary in Python. We can iterate through the array, and for each element num, we check if target minus num exists in the hash map, and if it does, we found our solution. Otherwise, we add num to the hash map and continue. So let's look at the implementation. We're going to define our method toSum. It's going to take in our integer array and the target that we're looking for. We're going to first create a dictionary to store the mapping of numbers to their indices. Then we're going to iterate through the array. So we're going to start off by creating a for loop to iterate through the array. Enumerate is a built-in function in Python that allows you to keep track of the number of iterations in a loop. It contains a count, which starts from the start and always defaults to 0, and a value obtained from iterating over the iterable object. In this case, the iterable object is our integer arrays. So we take the count and the value from nums. So we're going to calculate the complement of target minus nums in each iteration, and we'll take that complement and we'll see if it already exists in our mapping of the numbers to their indices. If it exists in the dictionary, what we're going to do is that we're going to return the pre-existing complement from previous iterations, as well as our current iteration, the indices of both, which will give us the answer that we're looking for. If not, we're going to add the current number and its index to the dictionary. So in our first iteration, we'll have 0, 2. We're going to check if the complement of 2 minus 9, which is 7, exists in num indices already. Since this is our first iteration, it will not exist. And so we'll go over here and we'll add 2 as the key in num indices, and its value will be 0. And so next iteration, when we look at 7, for example, 7 will calculate target minus 7 is 2. If 2 exists in num indices, and it does, right, because 2 exists as a key from our first iteration, then what we're going to return is the value of 2. Remember here what we stored the key as 2, or 2 as the key, and its value is its current iteration, so 0. In other words, the index of that number as we iterated over nums. So when the complement is 2, we use complement as the key to access its value in num indices. We'll get 0. We'll return 0 as the first value in our array. And then we'll return 1 as the second value in our array. 0 corresponds to 2. 1 corresponds to 7. And we'll break out of the loop. And our solution will be done. Now, let's run this to test it out. You can see there that when we print out the method with our two variables, our return, as I explained, is an array whose first index corresponds with the index of the first value of toSum, and the second index corresponds with the corresponding number that got us to our target. So 0 is 2, 1 is 7, 2 plus 7 equals 9, and we solved our problem. Now, an incredibly important thing, particularly in an interview, is to add some sample inputs to ensure it's working correctly. In this case, we had a very simple one, right? Our first two values gave us the answer, and we didn't have to continue iterating over the array. But we're going to add a couple more. So particularly in an interview, it's going to be helpful to test your function a little bit further. We have a couple of simple examples here. What I'm going to do here is I'm going to also include my assumptions of what I expect it to do, given my current implementation. And I'll check, first of all, that it works beyond our first two indices, right? So here I'm going to check that it's going to be able to properly skip index 0. We're looking for 6, so we're looking for 2 plus 4, which will give us back index 1 and 2, their corresponding indices. Here, very similar to our first implementation, it'll be 0 and 1. And here what we're doing is that we're checking in our implementation that when we don't have an answer, we properly return none if no solution is found. Here, no two values in this array will equal to 10, so we expect to go to none. Once again, print this out. And you can see that this matches my assumption, 0, 1, 1, 2, 0, 1 again, and none. Now, in more advanced interviews, you'll be expected to provide some sort of complexity analysis. In this case, our time complexity is O(n), right? We simply iterate through the array once. Our space complexity is also big O(n). We use a dictionary to store the mapping of the numbers to their indices. Pretty simple tutorial. We covered the two-sum algorithm, a pretty classic problem in computer science. We discussed the approach to solve the problem using a hash map and implemented the solution in Python. And finally, we tested the implementation with sample inputs and analyzed its time and space complexity. Very simple pattern that you'll want to repeat with all of the problems that you're studying for any interview questions.